coordinate axis, we know very well the two lines, one vertical and the another horizontal, intersecting each other at a point called origin with coordinates 0, 0. The horizontal x-axis and vertical as y-axis. So it divides the plane into 4 quadrants. Q1, Q2, Q3, and Q4. In the first quadrant, both coordinates are positive, x and y. In the second quadrant, it is negative, positive. Third quadrant, minus, minus. And the fourth quadrant is plus or minus. So, the points 2, 3, 3 minus 4, 5 minus 2, minus 2, 7, minus 1, minus 2. Like in this quarter, the first point, 2, 3, are both positive. Both x coordinate and y coordinate are both positive. So 2, 3 lies in Q1. 3 minus 4, which is positive and negative, plus and minus, it lies in the fourth quadrant. Similarly, 5 minus 2 lies in the fourth quadrant. Minus 2, 7. Minus plus, if you see, it lies in the second quadrant. And same way, minus 1, minus 2 lies in the third quadrant. So, just by observing, we can see in which quadrant the points lie. What about the points these points? Where one of the coordinates is 0. If you see 0, 3, the x coordinate is 0 and y coordinate is 3. Here, the axis of 0 coordinate is 3. Then it lies on y-axis. On y-axis at a distance of 3 units. Same way, minus 1, 0 lies on x-axis. That is negative x-axis. Negative x-axis. That is 0 lies again are positive x-axis. And 0 minus 2 lies on y-axis, which is negative y-axis. So, in this way, but just by observing following pairs, you can decide which quadrant they lie or on which axis they will lie. Further, of A is x1, y1. Coordinates of B is x2, y2. Okay. Then what is the distance between them? The distance formula. You know, so AB will be equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. We have already proved this. Okay, we have shown it. So the formula for the distance is AB equal to under root x2 minus x1 whole square plus y2 minus y1 whole square. Then, let's suppose the point A comes to positive. If O is the origin and P xy is a point in the plane, O is the origin and P is any point in the plane, then the distance OP is given by using distance formula. Using distance formula, OP is equal to under root x2 minus x1 whole square, y2 minus y1 whole square. That is, OP is equal to under root x minus 0 whole square plus y minus 0 whole square. So that gives you OP is equal to under root x square plus y square. So this is the distance of the line segment OP from O to P. If length of line segment OP, if O is the origin. Now, note that we can find many distances if the 2 points are given to you in the plane. Now let's come to the section formula. Section formula. Now, if suppose AB is a line segment, A having coordinates x1, y1, and B having coordinates x2, y2, and let there be a point P which divides the line segment AB in the ratio m:n internally. Let the coordinates of P be x, y. Let's find out then the values of x and y, or the coordinates of the point P, such that it divides the line segment AB in the ratio m:n internally. So, if a point divides the line segment AB with coordinates and B then x will be equal to internally in the ratio m is to n. Then x will be equal to mx2 plus nx1 by n plus n, and the y coordinate will be equal to my2 plus ny1 by n plus n. This way, m into x2 plus n into x1 by n plus n, m into y2 plus n into y1 by n plus n. Okay. The same way, if the ratio m is to n, the ratio m is to n can be written as m by n is to 1 or lambda is to 1. Say m by n is equal to lambda. So in this case, the coordinates of point P will be x is equal to lambda x2 plus x1 by lambda plus 1, and y will be equal to lambda y2 plus y1 by lambda plus 1. So this is the section formula. This becomes the section formula where a point P divides a line segment, given line segment in the ratio m is to n. Okay, where then the x coordinate will be mx2 plus nx1 by m plus n, and y coordinate will be my2 plus ny1 by m plus n. And if the same ratio m is to n is written as m by n is to 1, or say lambda is to 1, in that case the x coordinate will be lambda x2 plus x1 by lambda plus 1, and y coordinate will be lambda y2 plus y1 by lambda plus 1. What if with coordinates x1, y1, x2, y2 and x3, y3. So we need to find out the centroid, the coordinates of the centroids of the triangle. Coordinates of the centroid of triangle ABC. We already know that centroid is the point of convergence of the medians. So first, let us draw the median. AD, BE, and CR. The point G, centroid is denoted by G. The point G is the centroid. Now D is AD is the median. That means D is the midpoint of BC. So we already have the midpoint formula. So the coordinates of D will be x2 plus x3 by 2 and y2 plus y3 by 2. This becomes the coordinate of D. Then coordinate of E will be x1 plus x3 by 2 and y1 plus y3 by 2. These are the coordinates of the point E, because E is the midpoint of AC. And similarly, the coordinates of F will be x1 plus x2 by 2 and y1 plus y2 by 2. These are the coordinates of the point F. Okay. So now we also know that a median, the centroid divides the median in the ratio of 2:1. So here AD is median of triangle ABC. G is the centroid. Let G equal to what? X comma y, the coordinates of G. The point G is x comma y. And then AD is to AG is to GD will be equal to 2:1. So here we have m is to n is equal to 2:1, and the coordinates of T are x2 plus x3 by 2, y2 plus y3 by 2. These are the coordinates of B. And coordinates of A, we know x1, y1 are the coordinates of A. So now, using the section formula, we have G is equal to we get m into x1, m x2, 2 into x2 plus x3 by 2 plus 1 into x1 by m plus n, 2 plus 1, comma 2 into y2 plus y3 by 2 plus 1 into y1 by 2 plus 1. So that is equal to, this cancels, we are left with x1 plus x2 plus triangle ABC with coordinates x1, y1, x2, y2 and x3, y2. So, area of a triangle. ABC with A x1 y1, B x2 y2, C x3 y3 is given by the formula. Delta is equal to, or area of triangle ABC is equal to half mod x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is the area of the triangle. Now, let's know quickly what is the condition or collinearity of three given points in a plane. So let's if three points are given in a plane, they could be like this, they could be like this, one after the other. Okay? So in this case, the points are said to be non-collinear, and in this case, the points are said to be collinear. If you join that, you get a straight line. Okay? So, what are the conditions? The first condition is the 3 points, say A, B, C, are collinear. Say x1, y1, x2, y2, and x3, y3. They are collinear. Then AB plus BC should be equal to AC. AB plus BC should be equal to AC. This is the first condition. Secondly, if the points are collinear, the area of the triangle formed by them will be 0. The area of the triangle formed by the vertices A, B and C will be equal to what? 0. That is half x2 into y2 minus y1 plus x3 into y1 minus y2 will be equal to 0. So these are the conditions of the collinearity we need to satisfy. So with this, we circle. So circles you very well know. This is a circle to draw. Okay. It's a set of infinite points in a plane which are at a fixed distance from a fixed point, and it is this point, the fixed point is called the center of the circle, and the fixed distance is called the radius of the circle. Okay. So here, first let us know the secant. What is a secant? If we draw a line which intersects the circle in 2 points, if we draw a line L intersecting the circle in 2 points, then that line is called the secant of the circle. Secant to the circle. Intersects the circle in 2 points. Then the line A is a secant to the circle. This secant becomes a tangent. Now what is a tangent? Tangent is a line which intersects. Tangent is a line which intersects the circle in only 1 point. In only 1 point. So here, L is a secant to the circle. Now, let us draw another line. Line M. Let us name it as line M. It just touches the circle in 1 point. Say C. It intersects the circle in only 1 point, or it just touches the circle in only 1 point. Then here, the line M is the tangent to the circle. Just touches the circle in only 1 point. So, the line L, line M, is a tangent to the circle at C. The point C this is the point C. The point C where the tangent touches the circle is called the point of contact. This is called the point of contact. The point C is called the point of contact. Now, can you tell me how many tangents can we draw to a point on the circle? To a point on the circle, how many tangents can we draw? So if you see, we can draw infinitely many tangents. you can draw only two tangents from a point. From a point outside the circle. You can draw only two tangents to a circle from a point outside the circle. Then, let us know about the length of the tangents. If you see, this is a circle, this is the center of the circle, and this is the point P outside the circle. From the point P, we have drawn two tangents, PQ and PR. Two tangents are drawn, PQ and PR. Okay. What is the length of PQ and PR? We need to find out the length of PQ and PR. Let's join OQ and OR. Join OQ and OR and join OP also. If you see, we get two triangles, and the two triangles. Further, also we know that the tangent is perpendicular to the radius of the circle through the point of contact. A tangent is always perpendicular to the radius to the point of contact. So here the point of contact is Q. OQ is the radius. So PQ is perpendicular to OQ. Hence this angle is 90 degrees. Same way ORP is also, angle ORP is also 90 degree angle. Okay. So we see that OQP and ORP are right angle triangles. And OQ is equal to OP. They are equal because they are the radii of the same circle. Angle OQP is equal to angle ORP, 90 degrees. And further, OP is a common side for the two triangles. Okay. So in triangle OQP and triangle ORP, we have OQ is equal to OR, radii of the same circle. Then angle OQP is equal to angle ORP, 90 degrees, 90 degrees, and OP is equal to OP, common side. Common side for both the triangles. Therefore, triangle OQP is congruent to triangle ORP by RHS. By RHS. You see, PQ is equal to PR. Okay, so we get PQ equal to PR. So therefore, we see that the line segments or the segments of the ABC is a right angle triangle, right angle at B, and a circle is inscribed. Or let's draw an circle, and you need to find out the radius of this circle. What will be the radius of this circle? The side BC is 6 and the side AB is 8. Give it to you. In triangle ABC, angle B is equal to 90 degrees and AB is equal to 8 centimeters, BC is equal to 6 centimeters, given to you. Then, what is the radius of the inscribed circle? We have to find out. So, already we know the formula. The formula for finding that is R is equal to AB plus BC minus AC by 2. Okay. So let us first find out AC. What will be AC by Pythagoras theorem? Apply Pythagoras theorem to find out AC. Then AC will be how much? 10. So R will be equal to 8 plus 6 minus 10 by 2. That is equal to 4 by 2. R is equal to 2 centimeters. So this, we apply this formula to find out the radius of an incircle in a right angle triangle. Also, one more result is important. If a circle is inscribed in a quadrilateral, say this is the circle, A, B, C, D is a quadrilateral, and the circle is inscribed in a touching the sides of the quadrilateral at P, Q, R, and S. Okay. So in this case, the result is AB plus CD will be equal to BC plus CD. This easily you can prove using the concept that the tangents drawn from an external point to a circle are equal. So this is one more result, that is AB plus CD will be equal to BC plus CD. This is one more result, an important result. Based on that, if a parallelogram based on the same concept, there is another result. If a parallelogram circumscribes a circle, then the parallelogram is a rhombus. The parallelogram circumscribing a circle is nothing but a rhombus. And one more result is, if you see a circle and the tangents are drawn, draw a point outside the circle, the tangents PQ and PR, O is the center of the circle, joining this OQ and OP. Then the angle Questions?